Good morning, friends. Welcome back to online class. I am Shivashni Mudaliar. Today I am going to study about the fourth part of the alcohol, phenol and ether. Previously, we have done the preparation of the phenol. Now, we are going to study the the electronic structure of ether. So, here the ether is what? See here, CH3OCH3. The electronic structure of ether is what? Oxygen is having a two lone pair. So, the bond between the carbon and the oxygen is sigma bond. So, carbon and oxygen is having a sp3 hybridization. So, the angle between the COC is 111.7 degree. So, the electronic structure for the ether is given over here. What was that? CH3OCH3. That is what? The methoxymethane. So this is the example of CH3OCH3. So it's a methoxymethane. Fine. Let's go ahead. So see here the methoxymethane. So the common name for the methoxymethane is dimethyl ether. Second one is an example of a CH3OCH2CH3. So it's a methoxyethane. So the common name for the methoxyethane is ethyl methyl ether. And here CH3CH2OCH2CH3 is ethoxyethane. The common name for this is diethyl ether. And the next one is what? CH3O with the phenyl ring. So it's a methoxy benzene, or we can call anisole. Benzene ring with OCH3, so we can call anisole. Right? Or we can say methyl phenyl ether also. CH3CH2O benzene ring is a ethoxy benzene. So we can say it as a ethyl phenyl ether also, or phenetol. This one is a phenoxybenzene. In the previous lecture, we have discussed about the phenoxybenzene also. So the common name for the phenoxybenzene is diphenyl ether. So these are all the examples of the ether compound. Here you are having a double bond ring, double bond, as well as the ether also. So the name is given over here, 3-methoxyphenyl prop-1-ine, or we can say methyl propene ether, propenyl ether. Okay, so same over here, CH3CH2O CH3, this is the isopropyl. So it's a 2-ethoxy propane or ethyl isopropyl ether. Fine. Now, the preparation of the ether by the dehydration of alcohol. So, alcohol, take an example of ethanol, that is CH3CH2OH. In the presence of concentration of H2SO4, gives ethene, that is CH2 double bond CH2. Again, when reacts with the constant H2SO4, we get ethoxyethane or diethyl ether. So the dehydration of alcohol can be possible in the presence of acid. Product of this reaction will be either alkene or ether. It depends on the reaction condition. That is, example, dehydration of ethanol in the presence of sulfuric acid, which gives ethene at a 443 Kelvin temperature and ethoxyethane at a 413 Kelvin temperature as a main product. So step 1, see here, ethanol, so CH3CH2OH plus H. So H is added over here. So it's a protonated ethanol. The second molecule of the alcohol, which is act as a nucleophilic reagent to attack on a protonated alcohol. See here, CH3CH2OH reacts with a CH3CH2 and then OH twice, gives protonated ether, that is CH3CH2OH and then CH2CH3. What is happening over here? This oxygen is attached with the CH2CH3 and this hydrogen is taken place over here. That's why the name is given. See, OH will go up and this is over here. So it is formed like this. CH3, CH2 O plus H and then CH2, CH3. This is a protonated ether. The positive charge is there. That's why it's a protonated ether. Ether is formed by the elimination of a proton from the protonated ether, that is CH3, CH2, OH, and then CH2, CH3. So this water molecules is attached over here. So it's a CH3, CH2, O, CH2, CH3. So it's a ethoxy-ethane. See here, this is the ethoxy and then ethane. And then what is this? This is H3O and then plus hydronium ion. Okay, so the ether is formed by the elimination of a proton from the protonated ether in this way. By Williamson synthesis, English chemist Alexander Williamson discovered the nucleophilic substitution reaction for the synthesis of an unsymmetrical ether. So this reaction is called a Williamson synthesis, and this equation is very famous over here in a form of substitution reaction. So here sodium alkoxide, that is RONA, reacts with a haloalkane RX. In an unsymmetrical ether, it forms RO. Na is replaced over here and R dash is replaced over here. So it's an unsymmetrical ether NaX. If R is a secondary or tertiary alkyl group in a sodium alkoxide, then ether is also synthesized this reaction. That's why CH3, 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 ONA. So NaBr forms and CH3 is replaced over here. So it forms CH3O. So we can write this manner also, CH3C, CH3, CH3, and O, and then it is replaced with the CH3. So Na is taken out in this manner also. So always remember, Williamson synthesis reaction means substitution reaction, that is SN2 reaction. Our primary haloalkane can synthesize ether easily. So if secondary and tertiary haloalkanes is used, then the elimination reaction occurs to form the alkane. So therefore, ether can be prepared as also from the phenol. So phenol, when reacts with the NaOH, gives ONA, and then RX is aldehyde, alkyl aldehyde. So NaX is formed and R is placed over here. So it's an alkoxybenzene. Now, the chemical reaction of the ether. Ether compounds have less chemical reactivity. They do not undergo oxidation and reduction. Moreover, they do not react with the active metal and base. However, it gives some reaction with the strong acids. Generally, there are two types of reaction. There is a reaction involving cleavage of carbon monoxide, that is CO bond, or electrophilic substitution reaction occurring in an aromatic ring. Let's see which type of cleavage reaction CO bond is there. So this is the ethoxyethane. See, carbon CH3 CH2O. So it's an ethoxyethane. Reacts with the water. The hydrolysis gives CH3 CH2O. So it's a ethanol. A mixture of ethoxyethane and the dilute sulfuric acid is heated in a closed vessel under pressure. As a result, 2 moles of ethanol are produced by hydrolysis. The reaction with the hydrogen halide. So in this reaction, if a mixture of ethoxyethane or 2 moles of concentrated hydrobromide is heated at a high temperature, 2 moles of bromoethane are produced. That is CH3CH2O, CH2CH3 plus HBr gives CH3CH2Br plus H2. So the mechanism over here, ethoxyethane is converted to protonated ether by accepting H plus from the hydrogen bromide. So see here, ethoxyethane, like CH3, CH2O. So you can write in this format also. See how it is written, CH2 and then CH3, right? With O, and again it is attached with the CH2 and then CH3.